All right, so let's take a look at this real life example. Samantha purchased 2 jackets and 3 shirts. The total cost was $284.99. So what you want to do is pick out what A actually means, what X means, what B means, what Y means, and what C means in standard form in regards to this real life example that I gave you. So we'll start off with X and Y. X and Y, when you're writing it in standard form, represents the items or things that are being discussed. So what things are being discussed? Well, the things that she purchased were jackets and shirts. So I'm going to let X be the number of jackets she purchased. And it doesn't matter. You could have let X be the number of shirts. But the two things, I'm going to call it thing one and thing two. So I'm going to say thing one is the jackets that she purchased. Thing two would be the number of shirts she purchased. And I got that from here, guys. So again, just going to reiterate, says the variables X and Y represent the items or things being discussed. The items or the things that were bought were jackets and shirts. So those would be your X and your Y. All right, so A acts as the coefficient. Let's see what A acts as the coefficient of. So I'm going to go back to my equation. A acts as the coefficient for X. So if X represents the number of jackets, let's go back up here and find jackets. So if X is jackets, how many jackets did she purchase? She purchased 2. So you just put 2. 2 would be your coefficient for X. Now if B acts as the coefficient of Y, then go to your Y. Your Y was the number of shirts. Well, how many shirts did she buy? 3. So B is 3. And then as far as C is just some regular number, some constant. We have a regular number constant. I know that those jackets and shirts cost Samantha $284.99. That regular number ended up here being your total cost. So when I get ready to write my equation, it's fairly simple. You just put your A, which is 2, because it's 2 jackets, and jackets is X. So I'm going to put 2X. And then plus BY. Well, B is 3, and Y is the number of shirts. You just plus 3Y. 2 jackets plus 3 shirts equal what? Well, 2 jackets plus 3 shirts cost $284.99. There's my AX plus BY equals to C. My C is $284.99, and that's my equation. Again, that's 2 jackets plus 3 shirts cost that amount of money. All right, let's take a look at another example. So that's slope, that's standard form. Let's talk about slope intercept. All right, so slope intercept form is Y equals mx plus b, where m is your slope, we call it rate of change, guys. B is your y-intercept or your initial value. So the variables x and y represent what we call the independent and dependent variables. And you all watched the video on it on Monday and talked about independent and dependent variables. So I want to touch bases with you real quick on independent and dependent variables. Your independent variable will always be x. Okay, it'll be represented with the variable x. And you can pick it out when it's dealing with something in real life by asking yourself what happens first. So x, or the independent variable, will be the thing that happens first. Write this down. And then y, which is what we're going to call your dependent variable, will be the thing that happens second, okay? Or it happens last. But if you can just remember x has to happen first, or the independent variable has to happen first, you're good to go. So just make sure you know that, okay? Make sure you know this part. All right, I said again, m is a rate of change. And when we talk about rates, let me tell you something about a rate. A rate is something like 65 miles per hour. That's a rate because it's miles per hour. What we call a rate statement, guys. Or you may see something like 12 feet per minute. That's a rate statement because it's feet per minute. Or you may see something like $5 for each toy. Okay, so that's $5, and instead of per, you see the word each, which means $5 per toy or $5 for one toy. Now, if you see a percent can also act as a rate. So if you see 15% commission, which you're going to see in that next example, a 15% commission just means that someone is selling something, because salespeople make commission. So someone is selling something, and if they earn a 15% commission, that just means for every dollar worth of merchandise they sell, they get 15 cents. So they get to keep 15 cents per dollar. And that's on the things that they sell, guys. So for instance, if they sell something for $1, the company keeps 85 and they keep 15 cents. If they sell something for $2, they get to keep 30 cents. And the company gets to keep 85 cents twice. They get to keep 15 cents twice because it's 15 cents per dollar. All right, and B is your initial value. So I want to talk about this. So again, we just got finished talking about slope. Slope is that rate of change, okay? That's slope. But B is your initial value, or what we call a y-intercept. But when you have a real life problem, think of it as an initial value. The word initial means start. So put that in your notes. Initial means start. So basically, if you're looking at a real life problem, it's what do you start with? And that's going to be your B in your equation. All right, so let's take a look at this example. It says Daniel finds a job that pays him 15% commission on all his sales and a weekly salary of $500. Okay, so a 15% commission just means 15 cents per dollar worth of merchandise sold. So Daniel gets to keep 15 cents on every dollar. But he has a weekly salary of $500. So that means that every week he's guaranteed $500. But the only way he gets to keep the 15 cents on every dollar, he has to sell something. If he doesn't sell anything, he doesn't get 15 cents for any dollar because there's $0. All right, so the first question here asks, what's the dependent variable? All right, so I'm going to write what we call a dependent statement. So a dependent statement is going to deal with how much money Daniel's going to make. Daniel's money, or Daniel's check, the amount he makes per week, basically depends on how much merchandise he sells. If he doesn't sell anything, he doesn't really get a whole bunch of money. If he sells a lot, Daniel can make a nice paycheck. I'm just putting Daniel's money depends on what he sells. Or depends on his sales. Let's do it that way. Okay, now I also told you something else up here. So look up here. I'm going to mark it in green. Right in here. I said X, or your independent variable, what happened first. So before Daniel can get paid, Daniel has to sell something, okay? I'm going to go down here to this question where it has what is the independent variable. Independent variable is X. Again, it's a thing that happens first. Well, what does he have to happen first? Well, Daniel needs to sell something, okay? So his independent variable X will be the amount of sales he makes. If he doesn't sell anything, he'll still get a check because he has a weekly salary, but it won't be much of a check, okay? And the dependent variable is our Y. And in my dependent statement, it says Daniel's money depends on his sales, okay? So this will be the amount he earns. Or you can say the amount of his check. So just think of it this way. He has to sell something to make some money. So since he has to sell something first, that's our independent variable. Making some money is what comes next, so that's our dependent variable. Now let's take a look at our slope. Slope, it says find the number that is a constant rate of change. So Daniel is going to constantly make $15 per sale, not $15, 15 cents per dollar worth of merchandise sold. So because it said he will have a 15% commission, that's a rate, guys. We talked about a 15% commission as being 15 cents per dollar worth of merchandise he sells. So my slope will be 15 cents. That's what he's constantly going to make for every dollar he sells or dollar worth of merchandise he sells. All right, so B, it says find the initial amount of money or the amount he will make even if he makes 0 sales. So I'm going to ask you, looking at our word problem here, and I need to erase all of this. So I want you to go back up here and look at this. I'm going to give you a little bit of time to think about it. If Daniel doesn't sell a thing, what will his paycheck be? I mean, with 0 sales. If he's just a poor salesman, he got this salesman's job, but he can't sell a thing, is he still guaranteed a check? And if so, what's the amount of it? All right, this is what you should have come up with. That if he doesn't sell anything, if he doesn't get any 15 cents, okay, like 0, 15 cents, because he didn't sell a thing, okay, he still gets a weekly salary of $500. That's his check. So the B is 500. So when I get ready to write my equation in what we call slope-intercept form, this is slope-intercept form, guys. You're going to keep your Y and keep your X, but just know that Y represents the amount he earns, and X is what he sells. Again, he has to sell something to make some money. So since he has to sell something first, it's our independent or X. The money that comes next, that's our Y, our dependent. All right, but we're going to keep our Y, we're going to keep our X, but we know what they mean. And I can attach M, which is what he's constantly making per dollar worth of merchandise sold, to X, plus B, which is our initial value, even with 0 sales, which is 500. That would be the equation. Y, which is the amount he earns, is $15 for every X, where X is the amount of, not $15, 15 cents. And X is the amount of sales he makes, okay? So 15 cents for every dollar worth sold. I'm going to put for every dollar sale. Or every $1 sold. Plus 500, which is his weekly pay. Weekly base pay. When I say base pay, that means even if you don't sell a thing, that means with a sale of 0. Or let's just go with 0 sales. That's all that 500 means. What his pay is with 0 sales. So we got something for Y. We got something for X. X is just the amount he makes for every. It's the amount of his sales. And for the amount of his sales, he gets 15 cents for every dollar sold, or every amount he sells, plus 500, which is his weekly base pay with 0 sales. All right, so I'm just going to reiterate some things that you should have learned from the videos that you watched the past 2 days. Dealing with slope. Slope can be thought of as a constant rate of change between 2 points on the graph, or rise over run. And guys, this is not triangle y over triangle x. This means change in y over our change in x. That's all that means. So when you think about the change in something, that's basically the difference. It's basically your difference in your y's and your difference in your x's, okay? And this is specifically with a graph. Rise over run, you worry about that when you get to a graph. This I want you to use when you have a table of values. And there's another formula that you can use. Slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And slope is, we denote it with the letter m. But this formula you can use when you have 2 points. And keep in mind, a point consists of an x and a y. So if you have 2 of them, you have an x and a y in one set and an x and y in the other. That's why this little 2 stands for what's in the second order pair. So, and this little 1 stands for the y in the first order pair. This is the x in the second order pair, and this is the x in the first order pair. So I'm going to give you an example of what I'm talking about when you would use this formula. So if you had 1, 5 as an ordered pair, I'm going to say that's the first x and first y. And then if I had -3, 2 in the second one, that's the second ordered pair. So that would be the second x, and that would be the second y. All you would do is take the second y, which is 2, and write it down, minus the first y, which is 1, which is 5, and write it down, and put it over the second x, and the second x is -3, minus, tells us to subtract the first x. The first x here is 1. So all you do is just simplify that. So I'm going to come over here and rewrite that. So we end up with -7 over -4. A negative over a negative is a positive. So the slope here would just be +7 over 4. Basically, if you have 2 points and you want to find the slope between the 2 points, you can just use the slope formula. And the slope formula will be on that ACAP reference sheet, which I am going to show you. Okay, this is called the slope formula. So I gave you how to find the slope from a graph, how to find the slope from a table, and how to find the slope between 2 actual points. Okay? But we're going to talk about each one of those a little more in depth, okay? Slope is M. M, slope. Or better known as rate of change. All right, there are 4 types of slope, and you should already know this, again, based on the videos you've watched. Slope can be positive, and it will go upward toward the right. Slope, and this is in a graph, okay? I'm talking about in a graph. Slope can be negative. And that when I say in a graph, I mean, even if they give you 2 points or a table of values, those things can be plotted. They can be graphed. So if you plot them, this is what your graph should look like. If you plot them and the graph goes upward toward the right, it's positive. If you plot what's given to you, the points that's given to you, and it goes downward toward the right, your graph is negative. So I call this the uphill graph, which has a positive slope. I call this the downhill graph, which has a negative slope. And then a flat line, or we call a horizontal line, horizontal and flat mean the same thing, has a slope of 0. And then a line that's straight up and down, which is vertical, guys. Say vertical line has an undefined slope. Those are the only types of slope that you will ever encounter. It will have a positive slope. Your points may have a negative slope when graphed. They may have a zero slope when graphed. The points make a flat line, which means straight across. Or it may have an undefined slope if the points make a line that's straight up and down. All right, so what we want to do in this is write equations and describe situations. We'll describe what our M and B mean in the context of a situation if there's some real life problem that's given to us. So we're going to practice just generic equations, writing generic equations, and then I'm going to give you a real life situation and see if you can make connections and tell me, what does M represent? What's the slope? What's the slope talking about? What's B? What does it really represent? So just to reiterate again, for a table of values, you will have to use the change in y over the change in x to find slope or M. For a graph, you're going to use rise over run. You can rise up or you can rise down. If you rise up, it's positive. If you rise down, it's negative. And your run, if you run to the right, it's positive. If you run to the left, it's negative. But again, I'll talk more about that when we get to the graphs. And then, of course, the 2 points, that gives you M2. This is, again, called the slope formula. All right, so what we want to do for this next part is write an equation for each table. And the tables are going to be off to the right, guys. So I've given you certain steps to be able to write an equation for these tables. We're going to write our equation in y equals mx plus b form. And if you write your equation in y equals mx plus b form, there are two things you need. You will need m and you will need b. So I need m, which is slope, and I need b, which is the y-intercept, or what we call the initial value. If you have a real life word problem, think of it as an initial value, okay? Instead of a y-intercept. From the video, you should have learned that a y-intercept on a graph touches the y-axis, okay? If you graph it. It's the point where the line touches the y-axis. But in a real life word problem, it's what you would actually have if you had a zero. Like in the other problem, if Daniel had 0 sales, he still would have had $500. All right, so let's look at the steps. So we're going to follow these steps to write an equation for this table right here. All right, first of all, we need the slope. I told you we need that. So to find a slope from a table, it says use the change in y over the change in x. That's not triangle y, guys. That's not triangle x. That's change. That little symbol means change. So I want to know, and I'm going to start off with something that I know you know how to do. So you pick any 2 points you want to, guys. And if you have trouble with negatives, please don't pick the negatives. Pick 2 points you know how to add or subtract with. Because I know y'all will pick something knowing you don't do well with negatives. But you'll pick it anyway. So I'm going to pick those two. They don't have to be back to back. I could have picked 4, 0 and 12, 4. I mean, you can pick anything you want. Just pick 2 of them from the chart. And what you're going to do is you're going to start off with your y first because we're looking at the change in y. So you're going to start over here with y to find the change in y first. And then we'll find the change in x. We'll do that second because x is in our denominator, okay? So we're going to do our numerator first. So we're going to look over here in the y column. And I got to figure out what am I doing to 0 to get to 2? Well, I'm adding 2. So the change in y is simply 2. And then you have to go to the x's that you picked and figure out what are you doing to 4 to get to 8? Well, I'm adding 4. 4 plus 4 is 8. Now I'm going to simplify this slope. 2 fourths is the same as 1/2. 2 is half of 4. It's 1/2. So my slope is 1/2 again, guys. You didn't have to pick those two. Don't come up to me and say, Miss Blue, what does it matter what 2 points to pick, or do I have to pick a certain 2 points? I don't care what 2 points you pick. Just pick 2 ordered pairs, okay? Pick one x and y and then another x and y. because I could have chosen something like this. I could have chosen this one and that one. It doesn't matter. So you just think to yourself, what are you doing to -2 to get to a +4? Well, you have to be adding 6 because -2, which is left, and +6, which is right, gives you a +4. So you could have said, okay, the change in y. Let me write that a little better. You could have said the change in y here is 6. And then all you need to do is calculate the change in x. So what do you do to 0 to get to 12? Well, you add 12. 0 plus 12 gives me 12. But 6 is half of 12, so my slope is still 1/2. Make sure you simplify your slopes. So again, doesn't matter what 2 points you pick. No, just pick 2. All right, so I got my slope. And the next thing I need to do, step 2, which is find b. Again, b is called our initial value. Real life word problem. Other than that, think of it as your y-intercept for me, okay? All right, so to find your y-intercept, it tells you some things right here. It says pick a coordinate. Okay, a coordinate is just an ordered pair. So I'm going to go over here and pick anything you want to. I don't care. Just pick one. And if you don't do well with negatives, please don't pick a negative. All right, I'm going to go and I'm going to pick 8, 2. Okay, so I'm going to write down 8, 2. And your ordered pair consists of an x and a y. Your x is 8 and your y is 2. And then m is your slope. Well, we got our slope from step 1, so our slope is 1/2. So I've done step 2. So you're going to use step 2 to help you find b. Okay, so we're going to use step 2 to help us find b. So I'm going to go back to step 2 in a minute and then put my value for b. But right now I'm going on to step 3. It says substitute the values from step 2 in the equation below and solve. This equation is your slope-intercept form. You just plug in what you have from step 2, okay? Only from step 2. So from step 2, did I have a y? Did I have a y value? Well, if I look, my y value was 2. So I'm going to change this y to a 2. And then, after the equal is an m, well, did I have an m from step 2? Did I find the slope? Yes, my m is 1/2. So I'm going to change m to 1/2. When it's mashed together, it means times. So it's got to be times x. Okay? All right. Did I have an x in step 2? So go back up. Let's see if we had an x. There's an x from step 2. So the x changes to 8. I'm going to go ahead and put 8 over 1 so I have a top and a bottom. Plus b. Well, b we definitely did not have in step 2 because it tells us in step 2 to find b. So we definitely did not have a b. Okay? So all I'm going to do right now is simplify this. Top times top is 8 here. Bottom times bottom will give me 2. And I know, and I'll do it down below. I think I have enough room. I know that 8 divided by 2 is simply 4. 8 divided by 2 is 4. But I still have to solve for b. So what's on the side with b that's keeping me from having it by itself? That would be 4. So how do I get rid of 4 when it's farther from the variable? Okay, it's not attached to it. Well, you just change the sign. So it's -2 because that's to the left, that's to the right, and that's to the left. It's more to the left. So b is -2. All right, so do I know b? Yes, I know b is now -2. I'm going to write these right here. M again was 1/2. B was -2. Now I get to write the equation. Now, when you write the equation, let me tell you how easy it is. Only replace M and B with their numbers. When I say their numbers, what do they actually equal? Okay, so you're going to still have y equals mx plus b. But we're not going to replace y. We're going to keep y. And then after y, let me highlight these. There's my m and there's my b. I'm only going to replace m and b with numbers, okay? Now, do I know m? Yes, m was 1/2. Basically, you're going to keep x and y. And this is simply on step 4 when you get ready to write the equation. You're going to keep x and y as variables. This is all when you write the actual equation. All right, so I knew m was 1/2. I got x and then plus. Well, I'm not going to write the plus because instead of plus, you can put minus. It didn't have to be plus b. You can be minus b. But this is a -2, so I'm going to put -2. I could have put plus -2. But I prefer to go with y equals 1/2 x minus 2. So as you can see, I just attach my 1/2 to the x. And then I put my -2 behind it. That's all you do. Okay, let's try one. And I'm going to tell you something, guys. You could have easily found b from this table because here is an x of 0. Remember what I said up here about Daniel's problem? So this 500, which is the b, it's your y-intercept, is his weekly base pay. That means with 0 sales. So when your x is 0, when your x is a 0, that corresponding number. So here my x is a 0. So the corresponding number is also my y, my b. So the corresponding number, the corresponding y coordinate is -2. It's also my b. Now you can, that trick only works if you have an x of 0. So if I would have had 0, 5, my b would have been 5. Because it only works when you have an x of 0 for you to pick this out. Okay? I'm just saying for example. Now, down here, you do have another x. This x is 0, so you pretty much got your y-intercept. Your y-intercept is 0 too. But if you look at this table, do y'all see an x of 0 in this table? No, you couldn't do that one like that, okay? All right, all of them won't have an x of 0. So it's best to know all the steps. All right, let's take a look at this one. All righty. So first thing we're going to do is find the slope. From a table, you're going to use the change of y over the change of x. So starting your y's, I'm going to pick 2 points. I'm going to pick the ones that I know I can add, right? And I don't want y'all picking something with negatives if you're not good with it, okay? So I picked those 2. So what am I doing to 0 to get to 6? Well, I'm adding 6. So the change in y will be 6. The change in x, well, what are you doing to 0 to get to 3? Well, you add 3. 0 plus 3 is 3. And 6 divided by 3 is 2. So the slope here is just 2. All right, to find your y-intercept or your b, again, this is your y-intercept. You're going to pick a coordinate. I'm just going to pick 3, 6. Where I know 3 is x and y is 6. And then my slope, of course, was 2. And then I'm going to plug in this in slope intercept form, guys. Substitute, plug in. So here I am going to plug in. Do I have a y? Did I have a y in step 2? Yes, my y was 6. So put 6. All right, did I have an m? Definitely had an m. We find m here, m of 2. Put our m of 2. So I put a 2. Trying to color code for y'all. All right, did I have an x in step 2? I had an x in step 2. I had an x in step 2 of 3. So I replaced that with a 3 and its multiplication because these two are mashed together. Plus b. But did I have a b in step 2? Nope, sure didn't. That's why they asked me to find b. So now what I'm going to do is just multiply on this side. 2 times 3 is 6. Now I'm going to solve for b by changing the sign here. So that tells me that b is equal to 0. So I had a slope of 2, a b of 0. So now I get ready to write my equation in y equals mx plus b form. Well, you keep your x and your y variables, but you replace m and b. So y equals to m is basically, it's 2. So it's 2x plus y equals 2x plus b. B is 0. And you don't have to put that plus 0. You can just put y equals to 2x. When your y-intercept is 0, you can just drop the plus 0. It's not needed, okay? If your y-intercept is ever 0. But of course, I knew that because I had an x in my problem. And I told you if you have an x in your problem that is equal to 0, you got an x in your problem and your table is equal to 0. The corresponding y is your y-intercept. Let's take a look at this one. Now, this is a real life example. So let's take a look at our slope. I'm going to go with the change of y over the change of x. And I've got to figure out which one of these is x and y because in my table it's not labeled as x and y. So we're going to have to think about, go all the way back. We'll go back up here. So if it's a real life example and you want to know what your x and y actually are, your x will always be the thing that happens first. X will happen first. Okay, it's this right here. Whatever in your real life examples which has to happen first will be x, and the things that happen after it will be y, okay? So let's take a look. X is the thing that happens first. X happens first. So between hours and distance, guys, this has to be, and I'm going to go ahead and put this on your, this has to deal with train distances. Okay, it has to deal with train distances. So obviously for this train can go a distance of 150 kilometers in 2 hours. Just reading that. In 2 hours, the train can go 150 kilometers. In 4 hours, it can go 300 kilometers. 5 hours, it can go 375. Okay? So what has to happen first? Does time have to go by before the train can start? So if 0 time has passed, can the train go anywhere? Or does the train go somewhere before time starts? So I want you to think about that. Does the train move before time moves? Or does time move before the train moves? Okay. So I'm going to say some time has to go by for the train to move. You got to have time before you have distance. Okay. If 0 hours go by, the train hasn't moved. If it goes 150 kilometers per hour, it's not going anywhere if no time has passed. Okay. So what happens first is that we have to have some time go by. And I want to tell you something, guys. Whenever you're dealing with time, time will always be X because time always happens first. You can't do anything without time, okay? You got to have some time go by before you can do anything. So time is in terms of hours. And the things that happens next is the train moves. It goes a certain distance. So distance in kilometers is your Y. Or kilometers. Some of you may pronounce it kilometers. I don't care. Okay. So I'm going to go ahead and label this as X and Y. Now I can find slope because now I know that the Y is dealing with the distance. Okay. That's dealing with distance. And I know X is dealing with time or hours. Okay. Let me just put my units. My unit is kilometers and hours. That's going to help me be able to, because on this one it says write a description of the meaning of M and B in the context of the problem. Well, if you write your units, it's going to help you to be able to say kilometers. And remember, slope is like a rate. So I can say kilometers per hour whenever I find it. So many kilometers per hour. That train is moving at that speed, okay? But if you write your units, like the unit for distance, which is your Y, is kilometers. And the units for time, which is your X, is hours. So write your units next to that, okay? When we're dealing with a real life problem, that's going to help you with the description of what M and B actually mean. Well, I know, for instance, M, it's going to help you with what the slope means, okay? So let's find the change in Y. So this is really our Y. All right, so what do you do to 150? And I'm going to choose these 2 points. What do you do to 150 to get to 300? Well, you add 150. 150 plus 150 is 300. So the change in Y is 300. What do you do to 2 to get to 4? Well, you add 2. 2 plus 2 is 4. Now all I'm going to do is divide this out and see what 150 divided by 4 is. Hold on, guys. All right, it's going to be 37 point. Excuse me, I made a mistake. The change in x is not 4. The change in x is 2. We only added 2. So it's not 150 divided by 4. It's 150 divided by 2, which is 75. So the slope is 75. However, it's a real life problem. So it's 75 something. So basically, according to this part right here, the y represented the kilometers, x represented hours. So when I write this, I write kilometers per hour. So I'll just put 75. I put 75 kilometers per hour. That's what it means, okay? That train goes, or the train is going 75 kilometers per hour. And you're able to write that because you put your y unit on top and your x unit on the bottom. The y unit was kilometers. The x unit was hours. So it's kilometers per hour. All right, let's find B and talk about what it means. All right, so B, I just pick a coordinate. I'm going to pick 2, 150. All right, and 2 is my x. And 150 is my y. My slope is 75. All right, and I'm just going to plug in. So I'm just going to use what I have. Did I have a y? Certainly did. My y was a 2. Did I have an m? I certainly did. My m was 75 times my x. No, my y was not a 2. My y was actually the green one. My y was 150. My x was the blue highlighted one, the first one, x before y. So x is 2 plus b. So it was 150 equals to 75 times 2 is 150 plus b. Solve for b because we did not have a b. That's what we're looking for. So in this case, my b is 0 as well. All right, so my slope was 75. My b is 0. And I know my b would be 0 because if my initial value before any time goes by, remember your initial value can be found easily when you have an x of 0. Well, guys, the x was my hours, was time. If 0 hours go by, does the train move? No, the train doesn't move. Okay, so since the train doesn't move, the distance is 0. The distance is 0 kilometers at 0 hours. That makes sense. Okay, because no time has passed by, so the train hasn't gone anywhere. So that would make sense. Okay. So I just say at 0 hours, the train will have traveled 0 kilometers. That's what B means. Basically, the train's still at the station. That's what that means. The train is still at the station. You're going to need to know what each one of these means. The train hasn't left yet, okay? So, but the equation would just be y equals to 75x. Y equals mx plus b. So you keep your y and your x. And notice I changed m to 75. And you don't have to put plus 0. The plus 0, if you did put it, which just means the train hasn't moved, okay? So I'm going to write this all out where it makes more sense. So m is 75. That means the train is traveling at a speed of 75 kilometers per hour. And the B of 0 means the train's still at the station. Or the train hasn't moved. Okay, 0 kilometers. It's gone 0 kilometers, guys. That's all that means. All right, let's go on. Let's take a look at this one. I hate that I chose that all these are proportional. I needed some non-proportional tables. I may make up something right here, guys. Okay. Let me see what I could do. All right, we'll just go with this one because I'm a little tired. All right, it says using the table, write an equation to represent the situation and explain what it means in the context of the problem. Okay. Let's see. Let me do this. Because this, I don't like having these all proportional. When it's proportional, your B is always going to be 0. So we keep getting these initial values of 0. Initial value of 0 on the ones we've done. That means that that's a proportional relationship. I'm going to go with something that's non-proportional. So I'm just going to make up an example. And I'm going to say that, and we'll say this is paycheck amount. I'm going to make up something really simple, okay? And I need to erase this because I need to put something in here. Let me erase that, make it a little longer. And so here I'm going to put hours, and here I'm going to put pay. I'm not going to tell you which one is X, which one is Y. But I'm going to say, for instance, after 1 hour, and let me just do some calculations real quick. Then someone has $325. And let's say after, let's say 4 hours, they have $700. And I put after, and I'm just skipping around, 6 hours. Then I have, and I need to go back over this one. Well, here they have $400. I'll erase that. Here they have 400. And for the other one, let's see. They have 450. And we'll say for 10 hours, let's see. Let's say they have 550, okay? All right, so I'm going to ask what has to happen first. If somebody wants to get a paycheck and we got hours and pay, okay? So what has to happen first? Well, first of all, they got to work some time before they get paid. Nobody's going to pay you first before you work in hours. So this will happen first. Therefore, it's X. It's our independent variable. And then we get paid. So what happens last is your Y, okay? But what happens first is your X. You gotta work. Okay, you gotta put in some time before somebody cuts you a check. Nobody's gonna give you something for free, okay? All right, so here it's gonna be easier for me to pick out the slope. I'm gonna go with the change in Y over the change in X. Pay is like my Y and X is like X is my hours. So I'm just going to look at the change. I'm gonna pick 2 points. I don't know. These two look easy. So I'm gonna do these two. So what, and this is a Y now. This is my Y. So what am I doing to 400 to get to 450? Well, I'm adding 50 to get from 400 to 450. So the change in Y is 50. And what are you adding to 4 to get to 6? Well, you're adding 2 to 4 to get to 6. So I know my slope is 25. Okay. Now 25 what? Because this is a real life problem. So you just can't put 25. All right. So again, X was the thing that happens first. Well, you got to put in some time. You got to put in some hours. Okay. Y is the thing that happens last. Then you get paid. Okay. That's your pay. So basically, this will be you are paid. You're going to write a rate statement because let me go back over here so you'll be able to see it. I'm going to go back right here, guys. I'm going to do it in red. So Y, what did Y represent? Y represented our pay. What did X represent? X represented the time and hours. So basically this 25, you write a per statement in between. Just write per between. It's pay per hour. So it's $25 per hour. Somebody's being paid $25 an hour. Okay? That's it. That's a lot of money. It's pretty good. All right, now let's take a look at B. B is our initial value. In other words, if that person doesn't put in any time, do they get in the money? Because they might have one of those sales jobs, okay? They might be paid a base salary. So let's see. They may have gotten a bonus for the week. May have just been the bonus because I know some people that work at plants to get Christmas bonuses. So even if they didn't work for the week, they're still gonna get that bonus check. Okay, so let's see. And so what we'll do is we'll find B by picking an ordered pair. I'm just gonna go with 400. Could have picked anything you want. M was 25. Somebody's making $25 an hour. And I'm gonna plug in. Well, Y is 400. And if you're still confused about where I'm getting it from, Y is 400 right there, okay? Equals M, well, M is the $25 an hour, times X is 400, okay? So I put 400, no, X is 4. So I put 4 right there, plus B. All right, so I have 400 equals to 100 plus B. Now I just need to solve for B. So I'm going to change the sign here. So we get 300 equals to B. So M was $25 an hour. B is 300. Okay. Basically, I think this person got a bonus on their job. Okay. They got paid $300 without working any hours. I think that's a bonus, definitely. Okay. All right. But my equation would be, I'm going to write it in Y equals MX plus B form. And I got to keep X and Y. So it's Y equals to M, or what is M? M was 25. Attach it to X plus B, or what is B? B is 300, okay? So B always represents what it is when your X is 0. So when X is 0, that's going to be what B represents, okay? So what is X? X is your hours. So in this case, when X is 0, that means 0 hours. At 0 hours, someone still makes $300 when they didn't put in any hours. Okay. So someone still made $300 when they didn't put in any hours. So when I write this, I'm going to say someone makes, for the slope, This is what slow book got. Okay, guys. Someone makes $25 per hour. And then at 0 hours, he or she made $300. And I'm just going to put probably a bonus. You know, it might be something like a Christmas bonus. Okay, well, everybody gets it. Hope that makes sense, guys.